The universe has a habit of sending us postcards. On July 1, 2025, astronomers using the Atlas Survey telescope in Chile spotted another one. This wasn't just any old space rock. It was moving fast, really fast. Its speed clocked in at around 210,000 kilometers per hour, far too quick to be caught in our sun's gravitational embrace. Scientists quickly realized this object was on a hyperbolic trajectory, meaning it was just passing through. This was it, the third confirmed interstellar object ever detected, officially named 3I/Atlas. Our cosmic neighborhood just got a little more interesting, reminding us that we are part of a much larger interconnected galaxy. The discovery sent a ripple of excitement through the astronomical community. We've only had 2 confirmed visitors before this one. First came the enigmatic one, I/Oumuamua in 2017, a bizarre cigar-shaped object that baffled everyone. Then, in 2019, 2I/Borisov showed up, looking and acting much like a typical comet from our own Oort cloud. Each visitor is a precious, fleeting opportunity. They are time capsules from distant star systems, carrying clues about the chemistry and conditions of places we can only dream of reaching. 3I/Atlas represents a new chance to analyze a piece of another solar system up close, and scientists are wasting no time. Initial observations painted a picture of a rather large and intriguing object. Early estimates suggested its nucleus could be up to 20 kilometers wide, making it a veritable giant compared to most comets we see. It also possessed a distinct reddish hue, a color that often points to a surface rich in complex organic molecules, baked by eons of exposure to cosmic rays during its long journey between the stars. This color profile immediately sparked comparisons to other interstellar travelers and raised questions about its origins. Where did it come from? And what secrets was it carrying on its ancient frozen surface? The cosmos had delivered a new puzzle right to our doorstep. As 3I/Atlas drew closer to the Sun, it began to behave in ways both familiar and strange. Like a classic comet, it started to brighten, and a faint coma, a fuzzy halo of gas and dust, began to form around its solid core. This process, known as outgassing, happens when solar radiation heats the comet's surface, causing ice to sublimate directly into gas. Yet, the initial spectral readings were puzzling. They lacked some of the clear gas signatures astronomers expected to see right away. This early ambiguity left the door open for speculation, fueling a debate about the true nature of our third interstellar guest and what it might represent. One of the most peculiar things about 3I/Atlas is its path through our solar system. It's not just zipping through randomly, its trajectory is suspiciously neat. The object is traveling within 5 degrees of the ecliptic plane, which is the flat disk where all the planets orbit the Sun. Think of our solar system like a vinyl record, with the planets moving in grooves. Most comets from our own backyard, flung in from the Oort cloud, arrive from all sorts of wild random angles, high above or far below this plane. 3I/Atlas, however, seems to be sticking to the main highway, a path that makes it seem almost deliberate in its navigation. This cosmic road trip gets even stranger when you look at its planned flybys. The object's path is taking it on a grand tour of our outer and inner planets. It swung by Jupiter, and its trajectory lines up for encounters with Mars and Venus. Using a planet's gravity to adjust speed and direction, a maneuver we call a gravity assist, is a cornerstone of our own space exploration. It's how we send probes like Voyager and Cassini on their epic journeys. To see an interstellar object follow a path that so closely mimics a fuel-saving maneuver used by our own spacecraft is, to say the least, highly unusual and thought-provoking. This suspiciously tidy path has not gone unnoticed. A group of scientists, including noted Harvard astronomer Avi Loeb, quickly co-authored a study calling for intense monitoring of 3I/Atlas for potential technosignatures. Technosignatures are signs of technology, evidence that something is artificial rather than natural. Loeb, who famously proposed that Oumuamua could be an alien probe, suggests we should be watching 3I/Atlas for any tiny non-gravitational accelerations. Even a small, inexplicable change in its speed or direction could be a sign of propulsion, an indication that something is actively steering this object through our system. Of course, this is a fringe idea within the broader scientific community. Most astronomers argue that the trajectory, while interesting, is likely a cosmic coincidence. The universe is a vast place, and with enough objects flying around, some are bound to have unusual paths. They point out that its alignment with the ecliptic plane could simply be a statistical fluke. The gravity assists, they argue, are just a natural consequence of its path, not an intentional series of maneuvers. The debate highlights a fundamental tension in science: the line between open-minded inquiry and jumping to extraordinary conclusions without extraordinary evidence. The controversy surrounding 3I/Atlas is deeply rooted in the memory of our first interstellar visitor, Oumuamua. That object was a true mystery. It was small, reddish, and shaped like a cigar or a pancake. Most importantly, it showed a slight acceleration away from the Sun that couldn't be explained by outgassing because it had no visible coma or tail. This led Avi Loeb and others to float the idea that it might be a solar sail or some other form of alien technology. Oumuamua left us with more questions than answers, creating a precedent for scrutinizing any subsequent interstellar visitors with a healthy dose of suspicion and wonder. In contrast, our second visitor, 2I/Borisov, was a model citizen. It looked and behaved exactly like a comet. It had a prominent coma and tail, and its composition was similar to the comets born in our own solar system. Borisov was reassuringly normal, confirming that natural objects do indeed travel between star systems. 3I/Atlas seems to fall somewhere in between these two extremes. It shows cometary activity like Borisov, which argues against it being an inert piece of technology. However, its strange trajectory and initial ambiguous spectra give it a hint of the weirdness that made Oumuamua so compelling and controversial. The proposal to search 3I/Atlas for technosignatures is a direct result of these lingering questions. Proponents argue that we have nothing to lose by looking. Even if the chance of it being an alien spacecraft is infinitesimally small, the discovery would be so paradigm-shifting that it's worth the effort to check. They suggest pointing radio telescopes at the object to listen for signals, or using high-powered observatories to look for thermal emissions that might indicate an internal power source. They argue that it could be a camouflaged probe, designed to look like a comet to avoid detection, while it surveys our solar system. The mainstream scientific consensus, however, has pushed back strongly against this hypothesis. Institutions like NASA have stated that all available evidence points to 3I/Atlas being a natural object. Later observations by powerful telescopes like NASA's SphereX detected carbon dioxide in its coma, a definitive sign of cometary outgassing. For most astronomers, this closes the case. The slight acceleration can be explained by this outgassing, and the tidy trajectory is a coincidence. The debate is a classic example of Occam's razor. Is it a natural comet exhibiting slightly unusual behavior, or is it a disguised alien spaceship? The simplest explanation is usually the correct one. As of today, September 20th, 2025, the overwhelming evidence suggests that 3I/Atlas is a natural comet, albeit a fascinating one from another star. Its developing coma, its brightening as it nears the Sun, and the confirmed presence of carbon dioxide in its tail are all hallmarks of a classic icy wanderer. The more sensational theory of a camouflaged alien vessel, while exciting to consider, lacks any concrete supporting evidence. The scientific method demands proof, and so far, every test has come back with the same answer. It's a comet. But it's a comet from an entirely different star system, and that alone makes it incredibly valuable. Studying objects like 3I/Atlas, Oumuamua, and Borisov is crucial for our understanding of the universe. These visitors are our only direct samples of matter from beyond our solar system. By analyzing the light reflected from their surfaces and the gases boiling off them, we can learn about the chemical building blocks of planets and life around other stars. We can start to piece together whether our solar system is typical or unique. Each interstellar object is a new data point in our quest to understand planetary formation and the distribution of life's ingredients across the galaxy. This is why we get so excited every time a new one appears. The good news is that we are about to get much better at spotting these cosmic travelers. The Vera C. Rubin Observatory in Chile, with its powerful LSST telescope, is poised to begin its decade-long survey of the sky. Projections suggest it could discover dozens more interstellar objects over the next 10 years. This will transform the field from one of studying rare, individual curiosities to one of statistical analysis. We will be able to compare a whole population of interstellar objects, finally determining what is normal and what is truly anomalous. More data is the only way to settle these grand debates. So, while 3I/Atlas is almost certainly not an alien spaceship, the questions it raises are essential. It forces us to keep an open mind and to push the boundaries of our detection capabilities. The universe is under no obligation to make sense to us, and its greatest secrets are often hidden in plain sight, disguised as something familiar. Whether it's a comet, a probe, or something we haven't even imagined yet. Each new visitor is a reminder of the vast, unexplored cosmos. The journey of discovery is just beginning, and the sky is full of surprises waiting to be found. Keep looking up.